Okay, now we are going to check the design procedure for welded joint. How to solve the numerical related to welded joint by this simple way. I'll tell you the procedure. Now, as I told you that you should read the problem carefully. What number of welds are there? Welding structure, how it is that, what kind of loading conditions are there. According to that, we are going to decide the given structure. After that, step 1. The step 1 is very simple. It is related to this is the weld, so primary shear stress come in picture. As I told you, primary shear force is nothing but it is the load acting opposite to the direction of load. That we can calculate by total load applied with respect to area of weld. Area of weld we can calculate by width into thickness. Now second step will be about secondary force. We can calculate secondary force that is perpendicular to the radius from the structure, that is tau is equal to mr by j. This is again related with the twisting, that is torsional moment. So that twisting polar moment of inertia is in common picture due to flexural formula, that is mr by j. Now here m is the moment, that is p into e, eccentricity, the distance between load applied to the CG, by which we can calculate. R is the radius. As I told you, the radius is the distance from CG to respective weld, and polar moment of inertia. Now according to weld, this polar moment of inertia is going to change. As I told you earlier that for polar moment of inertia for first weld, I can calculate directly this formula, that is A into L square by 12 plus R1 square. This is for first weld. A, area of first weld, width into thickness. Now if welds are 2, I can calculate total polar moment of inertia for structure J1 plus J2, that is polar moment of inertia for first weld and second weld. By this way we can calculate. Now after calculation of this, we know this M, R, J, we also know the load area. Now remaining is resultant. That will be the third step. This will be the structure as I told you about the forces. Primary stress tau 1, secondary stress tau 2 with respect to theta. Here if I want to calculate radius, I can calculate radius. Now resultant is there. So resultant is tau is equal to square root of primary force plus secondary force plus twice of primary into secondary into cos of theta. By this way we can calculate resultant. Once we get the resultant, it is easy to calculate what will be the thickness of weld. Because thickness comes in picture in primary, that is W into T in case of area. So this thickness will be get after solving these steps. So these are the very simple steps for solving any kind of welded joint. I have drawn here flow chart. You can say check in the flow chart. First step is always related to the primary shear stress in welding. Second step will be the secondary shear stress force we can calculate. Third will be the resultant. Fourth will be the direct thickness you can get for any type of problem. So by this way you can easily calculate as well as you can also solve the numericals related to welded joint. If any query, you can ask me. Thank you.